right, so we're going to take a look at the study guide. So this is vector components from initial to terminal points. Let vector v have the initial point at -1, -2, and a terminal point there. That's just a little mistake. Determine the components of vector v. Okay, so again, to determine the components, you need to combine the first ones. So the terminal minus the initial. Okay, so the terminal is this one. So 3 minus -1 is 3 plus 1, which is 4. And -4 minus -2 is -4 plus 2, which is -2. So again, just make sure, if I write it down, how about that? So this will be 3 minus -1. And then the second point will be -4 minus -2. And you could just use a calculator so that you don't get it wrong because of notation, because of, adding, subtracting. All right, number 2, add in vectors numerically. Okay, so you're given the two vectors, find the sum of adding the two, write the resulting component of. So we're going to add these two together. All right, so that's -6 plus 5. So again, we add in the first component, the first part of the component, then we add the second part of the component. So that's -4 plus 3. And again, put that in the calculator, and that will be our answer. So that's going to be -1 and -1. All right, adding vectors graphically. I think this is a little bit easier because you'll make less mistakes, but it's just a preference. So given the two vectors, find u plus v. So you first got to be able to plot it. So 2 and then 5, that's plotted. -7, -2, -7, -2, that's plotted. So this is the vector u, this is a vector v. Find the sum, so you're just adding these two vectors. So when you're adding these two vectors, you have two choices. You can translate this vector to this one or this one to this one. It has to go initial to terminal. Then you have to, again, do initial to terminal. So it can go in any direction as long as you're joining. You take your first one. So let me do this one. Let me do it in order. So u plus v. So this is my initial. This is my terminal, right? Then I join the next vector at the initial point at the terminal. So terminal and initial, they join together. So the initial part for v is this part right here, and I need to join it here. So I'm moving this vector up here. To move that vector up there, I can just count the boxes. So I have -7 to the left and -2 down. So I'm here, I'm moving this here. So I'm going to go -7 to the left and 2 down. And just to make sure that you've moved it correctly, it should have a parallelogram. Like you should see that distance between this is the same. Okay, so when I move that, I'm going to get my resultant vector. Okay, and write the resulting component form. So my resultant vector is from the very initial to the very end. So when you're adding even like multiple vectors, you just keep adding them, and then your very initial to wherever your very end is, that is your resultant vector, which is your answer. In component form, x is -5 and y is +3. So again, we're going to check this numerically, but that's how you do it graphically. So numerically, add in the two vectors. So you would have 2 plus -7 for the first one, and then 5 plus -2 for the second one. All right, so you'd get 2 minus 7, which is -5, and 5 plus -2, which will be +3. So you see, doing it numerically or graphically, you're going to end up in the same place. Graphically is definitely better when you have a lot, like when you have a lot like this, because you get confused with the negatives. So adding vectors cumulatively, okay, is you have a multiple vectors, you're told to add all 4 of them. The easiest way is to put them on top of each other, right? So you put the first one, the second one, third one, the fourth one. Put them on top of each other. So then you have all of these added together. So I can see this going to cancel with that. -7 plus 1 is -6. We have 7 here, we have 6, 7, so actually 7 minus 7 is 0, okay? So when I add all of these, I'm going to get -6, 0, okay? So all I'm going to do is move the graphs. Again, the order that you move this does not matter. So let me start with C. I'm going to start, my initial point is right here, I'm ending here. So I need another initial, so just like before, right? Initial terminal, then initial terminal. So another initial, let me take A. So I'll go left 1, down 2. So starting here, my initial for A is right here. Left 1, down 2. So this is now where A is. So A is gone, I can cross that out. Now I'm going to, and again, the order doesn't matter. I can take B, I can take D, I can take whatever. Matter of fact, let me take D. So I can all out of order. So again, the initial of D is going to join the terminal of A. So I'm going to go right 1, down 4. So starting at A, right 1, 1, 2, 3, 4, down 4. This is going to be my D. Okay, so that's D, so this is gone. All right, so I just have one more, which is B. So again, I'm going to take B and put it right there at D. This is going to be -7, -1. So -7, -1. So that's my B. All right, and then your answer, so you keep joining initial terminal to initial terminal, and your answer is your very beginning, which was here, right, to the very end. The last vector I drew was B. So the very end is right here. So it's this answer from the initial point to the very end. And that's going to be -6. And I don't go up or down, so that's going to be 0. So you see how we get the exact same answer whether you do it numerically or graphically. All right, let's multiply a vector by scalar. So now we've looked at adding graphically and algebraically. Now we're going to look at multiplication. Okay, so we're given this vector, and now we're going to multiply by -2.5, I'm sorry. Okay, graphically. So what does that mean? All right, well, anytime you have a negative, you're going to negate whatever your vector is. So my vector is -4, 2, -4, 2, so that's vector V, right? And now I'm going to multiply all of that by -2.5. So this is going to stretch by 2.5, but in the opposite direction. So let me first negate it, bring it to this side. So if I negate this, several ways I can do this. This is going to be, so think of it as reflecting over this way, right? So this is going to be -4, 2, so it's going to be +4, -2. I'm multiplied by -1, so to speak. So this is my new V, okay, by negative. Now I got to stretch that 2.5 times. So let me first make 2 of them. So that's 1, so it's 4 and 2. So 4 and 2. That's my second one. And then now I need 0.5. So instead of going 4 and 2, I'm going to do 0.5 of that. So I'm going to go 2 and 1. So that's half 1. Okay, so I'm multiplying this vector by -2.5. So I'm going to negate it, then multiply by 2.5, 2.5 of those. And then my final answer in component form will be 10 and -5. Okay, now we can definitely check this numerically as well, right? So I'm going to put it on the side here. So -4, 2, and we're multiplying that by -2.5. So all you do is you distribute it in -2.5 times 4, times -4, I'm sorry, is +10, and -2.5 times +2 is -5. So you can do it numerically or you could do it graphically. Okay. Number 6. Given this vector, determine the value of, so now we're doing not just multiplying, but addition and subtraction as well. And this is asking me numerically, right? Yeah, numerically. All right, so that's simple. So you have 3 times u. So I'm going to do 3 times whatever u is. U is -2 and 4, minus 5 times whatever v is. V is -2 and 1. Okay, now we're going to go ahead and just multiply it out. So 3 times -2 is -6. 3 times 4 is 12. So 3u is that. Then -5 times -2. Okay, so we can actually leave, shall we leave the minus outside? So we can do one of two things. Actually, I'll do both, just so in case you pick whichever one you want to do. So -5 times 2 is going to be +10. -5 times 1 is going to be -5. And because I distributed a negative, it's a plus out. Yeah, it's a plus outside. If you didn't want to distribute the negative, then you would get, and I'm just going to write it on the side right here, minus still outside, and we're distributing just the 5. So this would be -10 and 5. Okay, so now it'll be the first one, which is -6, 12. Okay, so whichever one your preference is, the answer is going to be the same. All right, in this case, we're adding the 2, so we're going to add this. -6 plus 10 is +4. And then 12 plus negative 5 is positive 7. Okay, and we're just going to double check to make sure that we get the same answer here. So negative 6 minus negative 10 is going to be negative 6 plus 10, which is positive 4. And then 12 minus 5 is 7. So whether you want to distribute the negative as well and make it an addition problem or just distribute the number, it is totally up to you. All right, combining scalar multiples of vectors graphically. Okay, so now we're going to do that graphically. All right, so given this vector, these two vectors determine 4v. So 4 of these minus u. Click and drag, copies, blah, blah. All right, so the vector u is 4, negative 3. 4, negative 3, that's vector u. V is 3, 2, that's vector v. Determine 4 times v. That means I need 4 of these. So this is 1. I need 4 of them. So it goes 3, 2, 3, 2, that's 2, 3, 2. So 1, 2, 3. I need one more, 3, 2. All right, so I have 4 of these now. All right, 1, 2, 3, 4. So that's 4v. All right, now I have a negative. Anytime I have a negative, what do I have to do? I have to negate it, right? So it flips over to the other side. So instead of it being 4, negative 3, it's going to be negative 4, positive 3. Okay, so this is now my new u. Okay, so you negate it, you got to flip it to the other side or multiply the components by negative 1. All right, so now I have u. How many u's do I need? Just 1. If I needed more u's, I would keep drawing however many u's I have. All right, once you have that, now you could either take this and move it here, or you could take this and move it here. It's a bit faster for me to take the shorter one, so I'm going to take this and move it here. Because remember, again, you have to have it going in order. So this is my origin. This is my end. Now I need my origin of this one to touch that one. So I'm going to move this there. So this is going to be 4 to the left, 3 up. So 4 to the left, 1, 2, 3, 4, 1, 2, 3 up. So all I did was move this here. Now, again, just remember to make sure that you did that correctly. It has to look like it's going to be a parallelogram, like that distance is the same all the way through. All right, so now that it's there, then my answer is my very beginning, which is right here, to my very end, which is right there. So this is my resulting vector right here. And that answer is going to be 8 and 11. Okay, so 8 and 11. All right, magnitude from initial and terminal points. Okay, so magnitude. What are we talking about when we're talking about magnitude? We're talking about this formula here, a squared plus b squared. Right. All right, so first you have to find the vector v so you can do a squared plus b squared. Because right now it's telling you the initial point and the final point, but I need to find the actual vector. So remember, to find the actual vector from initial point and terminal point, it's always terminal minus initial. So that's how you find the vector v. So let's do that. So my terminal point, so here's my terminal point, which is negative 3. So it's going to be negative 3 minus, and this got cut off, but negative 8. So negative 3 minus negative 8, and then negative 1 minus 5. Negative 1 minus 5. All right, so my vector v is equal to negative 3 plus 8, which is positive 5, and negative 1 minus 5 is negative 6. Now, this is my vector v, but I want to find the magnitude, right? So that magnitude of my vector v will be the square root of a squared, so 5 squared, plus the, sorry, I didn't say square root, b squared. So b squared is negative 6 squared. So this is the square root of 25 plus 36, which is going to give me 61. And you can simplify this, but in the answer, they don't want you to simplify, so that would be your actual final answer. Okay. Number 9, find the vector magnitude and direction. Okay, so now we're still finding the vector and the magnitude, but in addition to doing these two, we're also finding the direction. So let's go ahead and get started. So you have an initial point at, oh, and this is graphically. Oh, this is great. Okay, let's do it graphically. You have an initial point of 3, negative 2. My initial point is 3, negative 2. That's my start. my terminal point where my arrow is -3, -4. So here's my arrow point. So this is my vector v. Okay, plot vector v. Boom. Move the vector so that the tail is at the origin. So I'm going to move this vector to the origin. And I need it to be, in terms of x, I need it to be 3 plus 3 is 6 and -2. All right, so I need it to go -6, -2. So all I did was move vector v to the origin. It is 6 units to the left and 2 down from the origin, 6 and 2. All right, now that we have that, it says find the component form. Okay, so the component form is -6, -2. All right, so it's actually really easy to do it graphically. All right, then the magnitude is, remember, the square root of a squared, which is -6 squared, plus -2 squared. And putting that in the calculator, that's 36 plus 4 is the square root of 40. And they don't want you to simplify it, so you're just going to put the square root of 40 in there. And then the last thing is to find the direction. Now remember, direction is the inverse tan of b over a. So that means the inverse tan of b, which is -2. Oh, actually, sorry, just 2. You don't need the negative. Over a, which is 6. All right. Putting that in the calculator, you're going to get 18 degrees. Make sure you are in degree mode. So hit the, the settings tab and then hit degree mode. Find vector magnitude and direction. Okay, so find vector magnitude and direction. It's just given to you in a different format. So this one was given to you as initial and terminal point as a vector v. This one is given to you in polar form. All right, so find vector magnitude and direction. So given u is equal to that, v is equal to that, find the sum. All right, so before I can combine them, I do first need to multiply these out. So go ahead and distribute that 5 in. So my vector v is really equal to, and I'm just going to leave this as exact so that I don't have to worry about all these decimals. 5 sine 160 and vector, oh, that's vector u. I'm sorry, that's vector u. Vector v, go ahead and multiply this 3 in. Vector v is 3 cosine 190 and 3 sine 190. Okay, now we're finding the sum, so we're going to add them. So we're going to add these two. So when I add this and add this, and again, I'm just going to leave it in exact format so that I don't have to round. So what I'm going to do is I'm going to write u plus v is equal to 5 cosine 160, and we're going to add it to 3 cosine 190. And we're going to do the same thing with the y's. All right, so 5 sine 160, 5 sine 160 plus 3 sine 190, sorry. All right, so that's my u plus v. So find the sum and write your answer magnitude and direction form. Okay, because this is u plus v, this is in vector form. So to find the magnitude, all right, remember the magnitude is the square root of a squared plus b squared, right? So you have to take this first one and square it, and this second one and square it, and then take the square root. All right, so that's going to be the square root of, now I'm going to put this whole thing in the calculator. So it's going to be roughly, and again, don't round until the very end, 7.65288864. And again, make sure that your calculator is in degree mode, minus this whole thing in the calculator squared. So that's going to be roughly 1.1891562 squared. So put this whole thing in the calculator, and you're going to get approximately 7.7. So the magnitude is 7.7, and we know that outside is the magnitude, 7.7. Now we need to find out what theta is, right? So remember, that is equal to the inverse tan of b over a, right? So the inverse tan of b, so again, b is this whole thing right here. All right, so 5 sine 160 plus 3 sine 190 divided by A, which is this whole part right here. So that's going to be 5 cosine 160 plus 3 cosine 190. Or rather, this part right here is going to give me B is this one, right? Because that's B, and then this is A. All right, so again, I'm putting it exactly in the calculator so that I don't get the rounding off. And that's going to give me roughly about 9. Okay, now we know that this U plus V, all right, because these are, so this one, this one's negative and this one is positive, right? So if I was to draw that, X would be negative and Y would be positive, it would be somewhere in here, right? Which means that this 9 is the reference angle right there. So this is 9. But that's not the answer they're asking for. They're really asking you, what is this? So what do I have to do to that 9? I have to subtract it. So it'll be, this whole thing would be 180 minus the reference angle of 9, which would give me 171. So my angle is 171. All right, subtracting vectors graphically, and I really should have put this in the front, but it's okay. So given these two vectors, so 1, 3, 1, 3, that's U. Negative 8, negative 7, that's V. Find the difference, U minus V. So again, we've done this prior, so you start off with U. So there's my U, minus V. Now remember, minus V, anytime you have a negative, you're going to negate it, right? So it's going to flip over. So this is negative 8, negative 7. If I multiply negative 8 by negative 1, you're going to get positive 8. Negative 7 times negative 1 will give me positive 7. So when I flip it over, it's going to go 8, 7. So this is my negative V. So I've negated this. Can you think of it as flipping it over this way or multiplying both coordinates by negative? All right, now that I have that, remember to add. So U minus V is the same as U plus negative V, because that's what I did. I negated it, right? So now I'm adding these two. So I either move this to here or I move this to here. All right, it's probably easier to move the shorter one, so I'm going to move U here. So remember, my initial to terminal, and then it has to go initial again. So what's the initial of U? And then to the final of the terminal of U. So it's going to be 1, 3. So initial of U right here, and then it's going to go right 1, up 3. So I just moved my U. And again, remember, you want to make sure that it looks like kind of the same on both sides, right? Or you can think 3, 1, 3, 1. Okay, so that's perfect. Then your resulted vector is your very beginning to your very end. So that's going to be 9 and 10. So your answer is 9 and 10. Now it says do this 2 different ways. Okay, so the first way is boom, right? The second way is instead of me moving anything, U minus V is going to be the same as me saying if I start at the terminal of V, start at the terminal of the second one and go right to U. If I do that, that will be the same as saying U minus V. If I don't start at U, but I start at the second and then go to the first. So that's going to be in the X direction, that's going to be 8 plus 1 is 9. So I still get 9 as my X. And then up, negative 7, that's 7 plus 3 is 10. So once again, maybe a faster way of doing this. If you only have 2, you can do that. You can either negate it and move, or you can start at the second one and go to the first one. All right, so we're going to take a look at plotting complex numbers. All right, to plot the complex number, 4 minus 6i, it's just like you plot x and y. This is your real axis. This is your imaginary axis. All right, so this is your real number is 4, so I'm going to go 4. And then this is your imaginary number. It has an I, negative 6. I'm going to go 4. And then on my imaginary, I'm going to go negative 6. And that's my point. Okay, so 4, negative 6. So real, imaginary. Real is x-axis, and imaginary is y-axis. All right. taking a look at rectangular to polar form. So we're just going to do a conversion. So to do a conversion, remember polar form, you need to have r cosine theta plus I sine theta. This is what it needs to look like. So I need to find r. Okay, so to find r, first let's go ahead and plot roughly where this is. So it's -6 this way, and then up 9. So it's going to be quadrant 2. So -6 up 9 somewhere over here. Okay, so this is -6 and this is 9. All right, so again, you plot it. And then you need to find r, which is the absolute value, this length right here. All right, so we can do this one of two ways. So draw a triangle, doesn't matter if I draw it this way or this way. What's the distance from here to here? This is going to be 6. The distance from here to here, this distance is going to be 9. So how do I find the rest? It's the square root of 6 squared plus 9 squared, which is equal to the square root of 36 plus 81, which is the square root of 117. And they don't want you to simplify it anymore, so that's that. So this is the square root of 117. And then the only thing I need to find is theta, right? So I need to find this right here. So theta is going to be equal to the inverse tan of b over a, right? So you'll remember b over a, or you can say imaginary over real. Okay, so that's what it is. So theta is the inverse tan of the imaginary number, which is 9. And again, you can just ignore the signs over the real, which is 6, because we're going to need to calculate what quadrant it is in. And since it's to the nearest 10th, that means one number after the decimal. So it's 56.3099. One number after the decimal, that's this. This 0 is not going to do anything. So theta is equal to 56, approximately 56.3. Now, that's not my answer that goes in here, because this is this right here, right? It's always my reference angle. Reference angle is the shortest distance from the x-axis to the line that you're looking for. So this right here, let me just make this a little bit clearer. This is what I just found. That's my reference angle. So I need to find what my angle is from the positive x-axis to the line. So what am I going to do? This whole thing is 180, and I'm going to subtract my reference angle. So it's going to be 180 minus 56.3, which is going to give me 123.7. And that's going to be my answer, 123.7. All right, looking at polar form. So now this time you're given to it in polar form. So remember, polar form is r cosine theta plus I sine theta. You're given in that form. You're given in this form, and you need to make it back into this form. All right, so to do that, all right, we are going to go ahead and distribute what is the r distributed inside. So this is going to be 2 radical 2 cosine 225 plus I, or 2 radical 2i, 2 radical 2i sine 225. Okay, now if you look at the unit circle and find out what cosine of 225 is, and remember the unit circle, x is cosine and y is sine, which means the first one is cosine and the second one is sine. So just be careful. If you look at the unit circle, you're going to get cosine of 225 is negative radical 2 over 2. And sine of 225 is also negative 2 over 2. Okay, so substituting the exact values for those using the unit circle. Outside I have 2 radical 2 here plus 2 radical 2i. Okay, so we're just going to go ahead and simplify this. So we're going to multiply this out. So when you're multiplying, I'm going to rewrite this so that I can show you. So what I'm going to do is just put it over one denominator. Whenever you're multiplying the numerators and multiplying the denominator. So I'm going to multiply the numerators out here. So it's going to be negative 2, and then I have radical 2 times radical 2, which is going to give me radical 4, or you can know the radical times a radical, and if the same number, it's just 2. So I'm not sure what your understanding is on that. Then on the bottom, I have 1 times 2, which is 2. Okay, over here, positive and negative is going to be a negative. And then I have the same thing going on. So on the top, radical 2 times radical 2 is going to be radical 4, or you already know it's 2, doesn't matter. And then there's a 2i out here. And on the bottom is 1 times 2, so that's 2. All right, let's go ahead and simplify this. Radical, first of all, if it's on the top and bottom, those cross out. Radical 4, square root of 4 is 2, so it's going to be minus 2 minus. And here, again, square root of 4 is also 2, so minus 2i. So going from polar form into complex, and this is how you go from complex into polar form. Okay, number 15, plotting polar points level. You don't need to show any work because you either know how to plot it or you don't. So because this is polar, remember polar has to do with, let me go to here. Polar has to do with r, right, and direction. Okay, so the radius and direction, and that's really what it is. So these circles here, these are the radius. So that's that one. That's that one. So that's the R. And then direction is what you're used to. So 0, 30, 45, 60, 90, 120, and so forth, right? You know what those are. So that's direction. So this is your R, and this is your direction or your theta. This gives you the direction. So I'm going to go negative pi over 4. Well, you need to know where pi over 4 is. So pi over 4 is 45 degrees, right? So that's the second line. This is pi over 4 normally, right? But you got to go negative. So it's the second line in the other direction. So positive is this way, negative is this way. So I'm going to go negative pi over 4. So that's 2 to this line right here. And then this R is, so it's on this line, and then it's 1, 2, but in the negative direction. So I'm going to keep tracing this and go 1, 2. So this is my point right here. Okay, so you just got to keep this in mind. If you're doing theta, this is positive, right? And this is negative. And then if when you're doing the R, it's the actual circles. The positive ones will stay wherever your theta is. Negative ones will be in the opposite direction. All right. Simplify this expression. Okay, so this is adding and subtracting complex numbers. This time we're subtracting. So remember, you got to distribute the negative just like you would if you were doing polynomials or something like that. So this is 2 minus 7i. Negative times a negative is a positive 2. A negative times a positive is a negative 6i. All right, let's combine what we know. So we got 2 plus 2, which will be 4. And then we got negative 7i minus 6i, which would be negative 13i. And that's really all that you have to do there. All right, number 17, again, just like you're kind of used to doing with polynomials, you're going to multiply these out. You can do the box method, you can do the FOIL method. I mean, there's so many methods you can do it in. I'm going to do the box method because that's just the simplest for me. So I'm going to put negative 6, negative 9i on the top, and on the bottom, I'm going to put negative 11 and 7i. And then I'm going to draw a box, okay? 11 times negative 6 is, negative 11 times negative 6, I'm sorry, is positive 66. Negative 11 times negative 9i is going to be positive 99i. 7i multiplied by negative 6 is negative 42i. And then 7i times negative 9i is negative 63i squared. And what do we know about I squared already? It's going to equal to negative 1, right? So let's go ahead and combine. So I have 66. This combined 99 minus 42 would be 57. So plus 57i. And then this is going to be negative 1, which is just going to change this from a negative to a positive, so that would be positive 63. And you can see that you have these two that you can combine, so that would be 66 plus 63 is 129 plus 57i. And you just want to make sure you have the number and then the imaginary number. Okay. And then finally, you're going to divide complex numbers. All right, so remember to divide, we want to multiply top and bottom by the conjugate. So that's 10 plus 9i, 10 plus 9i, 10 plus 9i. And what's going to happen is you're going to get rid of the i's on the bottom, essentially. So again, we're going to multiply this. I'm going to stick to this box method. I'm trying to think where to do it. Let me do it right here. So I have this times this, and this times this. Okay, so the top multiply together and the bottom multiply together. So on the top, I have negative 28 minus 11i. On the side, I have 10 plus 9i. All right, and I'm just going to multiply those out. So this will be negative 280. This times this. This times this will be negative 110i. This times this, 9 times 28, will be negative 252i. And then this times this will be negative 99i squared. Now again, remember I squared is equal to negative 1. All it does is changes that sign. So when we combine this, you're going to have negative 280. Combine this two, so negative 110 minus 252. I'm going to get negative 362i. And then this is just going to change that sign, plus 99. Combining these two, on the top now, it's going to simplify to negative 280 plus 99 is negative 181 minus 362i. All right, on the bottom, I have a difference of squares, and anytime I have a difference of squares, like the same numbers minus and plus, I know I squared the first one, so that would be 100. And because it's a difference of squared, this is minus, and then you square the second one, so that would be 81i squared. Well, again, what do I know about I squared? It's equal to negative 1, right? So this is going to be, let's do negative 181 minus 362i all over, and we got, all this is going to do is change the sign. So it's going to be plus 81. So you're going to have 100 plus 81, which is 181. And that's really what all you can do except for simplifying. So let's go ahead and simplify. So I can write this as two separate fractions. Like I can do this, negative 181 over 181 minus 362i over 181, because I need to simplify. This is going to go one time, so this is negative 1 minus 362 divided by 181 is equal to 2. So minus 2i. So always just be careful to check if you can simplify there at the end. You can write them as two separate fractions and simplify them individually. All right, so that's pretty much all it is.